The development of the prototype. The prototype consists of two main sections, the drone itself and the delivery mechanism. Discussing the assembly of the drone, a ready-to-build drone set was ordered and shipped from Amazon. The bottom half of the drone frame was manufactured first. Then the brushless motors, electronic speed controllers and a power distribution board were attached. The flight controller and the receiver were added last along with the top half of the drone frame. The assembly of the drone was time-consuming as screws and mounts had to be strongly tightened and the given instruction were unclear. The drone was successfully working without propellers on indoors, which meant that a majority of the drone was working. However, when the drone was then flown outdoors, it flipped upside down during takeoff, damaging one of the 4 propellers. So, new propellers for the drone had to be ordered and be used instead. With the new propellers, the drone was flown again, and after multiple crashes, the drone was able to be flown somewhat stably. The damaged landing gear as a result of one of the unsuccessful flights was repaired through tape. Now that the drone itself was in a somewhat working order, the rough design for the delivery mechanism was created through a 3D design software. The design was printed and was attached to a servo connected to the Arduino to test whether or not the design would be suitable. Major changes were made to the initial design so that it would be more suitable for the delivery mechanism. An Arduino Nano was used to control the servo due to its small size and lightweight. The idea for the delivery mechanism is that the hook, one in blue, will be used to lock and release the payload in a keychain. When the hook is inside the range between the 2 golden holes, the product would be held onto the drone. When the hook leaves the space between the 2 holes, the attached payload would fall. After an error in the servo was fixed, the delivery mechanism was also in working order. After brainstorming multiple alternatives to powering the Arduino Nano, it was found out that the Arduino Nano could be powered through the power distribution board on the drone. However, the Arduino burnt when the power from the drone was connected to the 5 volts pin on the Arduino Nano due to high power input. It turned out that power input higher than 5 volts had to be connected to the VIN port. As the battery was 11.1 volts, it was no Sherlock that the Arduino burned. With a new functioning Arduino Nano, the power distribution board was connected to the Arduino Nano using alligator clips and jumper cables. This time, power from the battery was connected to the VIN pin of the Arduino. Now that everything was connected into one body, the prototype was turned on and tested one final time. The delivery mechanism was rigorously tested and the trim was also manipulated to allow a more stable flight of the drone. Testing of the prototype. The prototype was tested on the next day. While there were several crashes at the beginning of the session, the prototype was able to function to the design task as it was able to successfully release a payload, a GoPro, mid-flight.